هاي ضيوفنا ليس مرحبا. اليوم نتكلم بايثون. Okay? How was my Arabic? Very bad, I know. Anyway, so today we start with Python. This is a very long workshop, so brace yourself because you will end up drained. I know because I end up drained. So very few things. First of all, who am I? My name is Didier Barradas. I am part of the KAUST Visualization Core Labs. I am one of two data scientists. We're always open to help you with your data science stuff. We give these kind of workshops fairly regularly. I am in charge of the basics. Then the advanced course are in charge of Abdul Ghafur Halimi. Next week, he will have workshops for example, machine learning, okay? Basics of machine learning. Also, we have Ronald Barrera Sicat, who is a wizard with visualization and everything related to AR. James Kress, which is another wizard that he can basically visualize large data sets like weather data sets and so many other data sets. Now he's playing with some very cool tools from NVIDIA. And our boss, Sobhegani, he already knows data analysis and pretty much data-related visualizations too. Okay, so if you have any project that you want to work on, we're very open to collaborate with you, okay? And any other question, just drop an email, drop by the office. We usually are there. If not, prepare your Pokeballs, and when you see us, try to capture us. Okay. So what is Python? I forgot to tell you, I am not a computational scientist by training. I am actually kind of a biologist, right? But I love computers, like a lot. And that helped me with my research for a long time. So one of the things that I have to learn after I learned Perl, which is a very old thingy, is the lingo. One of the things that you have to understand is interpreter is not the same as compiler. So for computer people, one thing is talking to the machine directly, and the other is like a layer of you translating stuff into machine language. This is why Python is called a high-level interpreter, because it's like a top layer, and then it trickles down to machine bits and bytes. The compiler is different. The compiler literally is you putting everything into the language of the computer. So that's just lingo. But the real thing is very flexible. So for example, who said the phrase, "Be water, my friend"? You know this excellent philosopher from China? Bruce Lee. You found Bruce Lee. So when he was saying, "Be water, my friend," he was like, adapt. And Python is technically speaking the water of all computational languages, because it's a very broad umbrella of different libraries and different programs you can use. Basically, nowadays, all streams of science have their programmer that knows a little bit of Python, and they manage Python for all intents and purposes. Okay, and then it's easy to install, and I put that quote unquote because it depends how much do you want to do about the installation. If you came to the Conda workshop that I gave this week, Sunday, you see that it's pretty easy when you have the right tool. We installed several Conda versions during that workshop, and pretty much with one line. So the other thing is that the history of Python is very curious. You have now a YouTube movie that you can watch in YouTube, and was done by a Dutch guy named Guido van Rossum, or Guido van Rossum, I don't know, but Van Rossum, so Dutch, remember that one. So one other thing is like Python does not have anything to do with snakes. It's not that Guido liked to be an herpetologist or of any sort of kind. He liked it Monty Python Circus, the British comedy, if you believe that British have a sense of humor, okay? So next thing, why would I learn Python, right? Why from all the varieties of different choices, you choose Python? Very simple, very popular right now. It's very flexible. is highly integrated with everything related to coding, like, for example, VS Code, PyCharm, and Eclipse. Those things are tools for developers, meaning that it's a window that you can see, interact with, to create a Python script, a Python program, but with a lot of tools that highlight things that are usual errors. Probably I will just showcase how we did it when we were in the Stone Age, because it's not easy. And you can install packages very easy. One of the things that is very used for Python is called pip. There is a new one called UV, and that one is even faster, but all comes back to is really, really easy to install whatever tool you need for whatever task you are about. And for data science, it's been a long run, but it's incredible because people start to use, for example, data frames, which is a fancy word to say a worksheet from Excel into the computer. And then you have things like Rapids, which allows you to use the GPUs very easily, seamlessly. Dask, which is also for high amount of data that you can transfer. NumPy is the one that makes all scientific work from Python to actually work. That's a very important one. And statistical models, because everybody here knows a little bit of statistics. And that's usually a good case scenario that you know your numbers. Well, so how do I learn Python and why I have this slide here? One, this is a very small workshop. I do not pretend that I'm going to teach you all there is about Python and everything that I know about Python, because it takes like at least 3 months. Okay, so in this one, we're going for the basics of the basics. And from there, I hope you pick up your slack, and then as a good master or PhD student or researcher, you get all the information and you munch through it. So there is one thing that is called the Python tutorial, written by the Python persons that rule the world of Python. One of them was Guido van Rossum, which, by the way, I should point out that he was like a benevolent dictator, because he was on power until very recently, changing the things about Python that he was the main decision maker. And then he was toppled for a very good, very large group, but not for the reason you might expect. But that's the Python tutorial. If you don't know, there are plenty of tutorials of Python, this one included. And even in KAUST, we have one student now, Dr. Burlachenko, he recently defended. He did like a very extensive review of Python that you can get and read. All right? There is a lot of, there is a lot of material for you to lean on. Okay. Next one should be that I'm telling you that this course is basically based on the materials of the Carpentries. The Carpentries is an organization that dedicates its time to teach the basics of computational science to people that want to learn. Usually, for example, ecology or genomics or chemistry. You can find a lot of material of there. I am a certified instructor from this organization. Thus, I'm using his material, and I promote also their core values. Okay. So, what are we going to use today? If you came last Sunday, you know that there are two things that I want to use. One is the binder hub from KAUST. We're going to use it because I think it's a really very easy way to not install anything in your computer, and you can follow along, and you Microsoft users don't have to suffer through the same problems of installing the things. But if you want to install Python in your computer, you can install Anaconda Navigator. So let's start with the setup. What I want you to do is to visit this webpage, wiki.bis.kaust.edu.sa. Please try to find the training events, and then please find the Data Science Tool Workshop segment. It's in yellow for those that are not colorblind. And please find Introduction to Python. This one is from last last semester, so it still has Python, PyTorch, and Git. But now you should see the Python one. Okay? wiki.biz.kaust.edu.sa. Well, you know where to find it. I know. Okay. If you click in Introduction to Python, you will see something like this. This is the web page from, you can get all the resources that we're going to use in this workshop. There is a section that you will see on the left that says workshop materials. There are two things there, the slides and I think the Etherpad. For this workshop, we can use the Etherpad because the Etherpad is a collaborative notebook where you can place your questions or bits of code or stuff like that, okay? It's anonymous, so you can put your whatever name you want. I will put myself there also, in case you have another question and you don't want to ask it out loud, no problem, you can put it there, I will check it, okay? The most important part is like you have to get to the public binder. You click in that link that says public binder, and it will take you to this web page, the GitHub page that we have. Okay, in that GitHub page, you scroll down and you must find something called binder. There's a flag called binder. It's all the way down. And then you click in the one that says KAUST binder. How can you download binder? So binder is a cloud instance for a virtual computer. So technically speaking, you don't download anything. But the programs that are installing that specific binder are already there in the environment.yaml file. Okay, so just to summarize, you go to this GitHub page, you find the one that says launch binder hub for KAUST specific, because that's our thing, that's our local thing. You will see the binder flag going around, and it will deploy something like this in the left. That basically is what we're going to use. You will see some files over there to your left. And I want you to notice that you will see that Python 3 PyKernel there that says not on notebook. Okay? We're going to click on that and use that. For those of you that want to install Anaconda and have something similar to this, you can use the Anaconda installer and then fire one Jupyter Lab. You just click in launch, and this will be enough for the moment. So once you do that, you have this thing called GUI, Graphical User Interface, that is known also as Jupyter Lab. So this is one of the things that actually revolutionized data science, because this thing made easy for anyone to use Python and to write code very clean and to actually share it. Okay, so just click on the IPython iKernel where it says notebook, under notebook. So once you have that, you will see a page that says untitled.ipymv. This is known as the Jupyter Notebook. Okay, for those of you that are very new to this, the Jupyter Notebook technically is like that. It works like a notebook. You can scribble there a lot of things. And it's used to prototype stuff, meaning that if you're not completely sure of one specific part of your code, you can put it in one of these cells. It will run independently from all the program, and you can try to fix it or try to enhance it. Also, you can basically do a bunch of other things there, but we're not going very deep into it. You can copy paste it. Like you see in the red square, you can save it. The plus adds a new cell. You can cut this cell, paste another cell. You can play that. You can stop it of execution, and so on and so forth. Okay, a very didactical tool, but it also is very powerful in that sense. Okay, so let's honor the big tradition of Hello World. So in the first cell, please write print parentheses Hello World and press enter, Control Enter. Or if you cannot execute it, please push play, the play icon that is on the top. Just like that. Print parentheses, quote unquote, Hello World. And once you execute that, you have printed Hello World, correct? So if you succeed, congratulations, you're a computer scientist now. Good. So the question is on the line of, I know where you're coming from. The spaces doesn't matter. Python is very flexible. You do not need to put everything close to each other. In other programming language, everything matters. Where you put, how many spaces you put, and everything. In Python, you can ignore them. As a matter of fact, you can change those quotes, single quotes, by double quotes, and still you will get Hello World. So in Python, there are no hierarchy for double quotes or single quotes, but please just stick to one style. Don't mix them. Can you mix them? Yes. You shouldn't, because it makes the thing confusing. For other programming languages, it does matter how many spaces and if you have normal quotes or double quotes. Okay, so following that, I want you to do that, import this. Yes? So if you want to put two sentences in the same print, yeah, like a return, card return, that's what you mean. There's special characters for that. If you want to do a card return at the end of Hello World, you have to do /n and the next phrase. That could be Hello World, I don't know, happy day. But please also after this, use import this, okay? Once you execute import this, tell me, what do you see? The Zen of Python, exactly. So I give you a moment to read it and take the philosophic part of Python. You will find a very particular line. So please go ahead, read it. Tell me the particular line. Yeah, I see a confused face over here. He found it. So in the import these, they basically tell you how is the philosophic part of Python. It's like everything must be simple. You don't have to overthink things, which is something that we all scientists are basically guilty of. It's like we want to do over the top things when you can do the simple thing and get it done. That's basically it. This is what it's saying. There's one line that says, even if you're Dutch, that's an actual joke to the Guido van Rossum guy, because he actually was able to convince everybody to just do the simple thing. Even though it's not obvious for everybody, or for him, it might be not obvious. But that's the idea. Keep it simple, keep it lean. Don't overshoot the things. Okay, I will leave over here. I will join you now because we are going to start with variables. So if I go here, I can just click in Binder Hub. If you're outside KAUST, you can click the other one that is beneath, which is launch binder, it will technically do the same thing, but this is a resource for us, okay? So when I do this, I am in untitled IPython-MP. This button here says that it's not safe yet. So if I do Command S, I can rename the file my first notebook. So one word of advice: start putting numbers on front of your notebooks like that, like 0001 or something like that, because the more you develop a program, the more notebooks you start piling on. So just for remembering who was first, for your own sake, put numbers like 00 or 00000 just to keep track of it. Otherwise, it will come to a moment when you have like 20 or 15 different notebooks and you cannot track which one was first. Okay. These notebooks are locally safe right now. So once you are disconnected from the binder hub, they are all erased. But you can download them. There is a here in file, if I recall correctly. Yeah, download. Okay. So whenever you are done with the workshop, and if you want to or you need to go, you can download this and then continue later. Okie dokie. So import this, for example. Zen of Python. And yeah, so beautiful is better than ugly. There is a very ugly things sometimes because you're just, I don't know, 5 years into your PhD last month and you are just trying to see the light of the day. Things get messy, you know it. But okay. So let's start with variables. Everybody here get to understand what's a variable. We all had that math class, right? So in this case, a variable, especially in Python, will start with underscore. If you see R like this in a program, do not change it. Like the underscore in front of the name of a variable, it's a tell sign that this is very important for the program. And you probably shouldn't move it unless you know what you're doing. Okay? Just heads up. What we're going to do is technically like this. AR underscore variable. Now, for those that are my Windows users, I know this is going to sound almost like anathema to you. Do not use white space or blank space. Use underscore. There are no such thing in Python or in any computational thing that looks like this. AR, let's put this here. AR variable 00 is going to tell me that there is a problem with syntax. Okay? For all your life, you probably are being very proud of being organized, and your title says like the space new space notebook. That doesn't apply anymore in this world. You have to use underscore, at least underscore. Okay? Now, what's in a name? You also need to understand, back in the day, these guys that founded Python and everything, they were struggling for memory. They were fighting to get all the bits and bytes in place. So they used to do something like this, like AR, something like this, which actually means nothing unless you know what is he thinking, right? What's AR stand for? Who knows? But now you can do like something like force equals gravity times mass. Okay? You don't have this restriction. So when you are doing variables, when you're assigning or writing your code, think comprehensively. Do not struggle like, I will remember this. No, you won't. In 10 days, you will forget what's AR standing for. And I know because it happened to me. So be comprehensive, okay? As a matter of fact, let's do this. If I do gravity underscore Mars, I know is 3.71. And then we can do mass equals, I don't know, 100. Now, let's do 93 in kilograms. So I can put even name. And to declare a name, I have to use the quotes. Age, let's say 25. Okay. So you can see the change on, if I do, for example, force, and I have the force equation, and I put my weight on Mars, now I know that it's the force on Mars. At least I know that, okay? That's what I mean. Get your names clear, be comprehensive. Now, what I want you to do in this moment is please add your age, your first name, and your last name, okay? Declare those variables. When you're declaring, for example, your name, use the quotes, okay? Go ahead, type it. Yes. Yeah, I mean, you have to first, yeah, the first thing is you declare your variables, and then you can use your equations, because Python will try to find where are these variables. For example, like you were telling just now, if I don't have force equals mass, let's say force at Earth equals mass times just gravity. If I didn't put gravity anywhere before, there is a problem, because it will tell you, I don't find that gravity variable that you're telling me to use in this equation. So you have to define first your variables. Is the language case sensitive? Absolutely yes. If you have this, for example, gravity Mars, it will tell you, where is this capital G gravity Mars thingy? I don't find it. So your variable name has to be basically copy paste every time, but fret not, because actually Jupyter Lab has another magic on there. If you type, for example, gr and then tab, it opens that window that you see over there with an I, for instance. That's your variable that you already did. I have gravity Mars on top, and then I can just click there and autocomplete. So Jupyter Lab is helping you to do stuff. You don't have to remember all your names if you have several. If you put M, it will be very, it will M and tab, and it will deploy a bunch of things that it has. For example, a function called max, a function called mix, something called magic that we will use later. But it also has the instance Mars, meaning the instance is the variable, okay? Times gr, and then you have gravity Mars. Okay, I will get this. So you all got your name, your last name, and your age, correct? Now try to print it. How would you print three things together? With a comma, yes. Somebody was very keen on the logic. But yeah, let's say you want to print something, and then it's just name, comma, age, comma. And in my case, mass. Okay. So of course I'm lying about my age, but not about my mass. But this is a very ugly way of how you actually print stuff, right? It actually doesn't have like any context at all. We are very contextual animals. So we can change that with a very, very small thing. If you do print and then you add f, and if I recall correctly, these two thingies, what's the quotes, single quotes, that's the thing. So I can do my name is Slim Shady. Okay, so it's very easy to give format to print right now. It's like you just put F and then the quotes, and then you can put any other sentence that you want. Like, for example, we were discussing the return car wheel. What is this? My age is curly brackets age. My mass is mass. Oops. And okay. So far so good? Because it stands for format. It means format this output. So this is why you need it. Actually, this is the short way to do the same thing. Instead of F, you will use format, dot format at the end, and then name, age, mass. You take this from here. Over here or here. There you go. So you have basically two ways to do it, but I like the first one because it's pretty neat. Like one F at the beginning is like format this. It's basically like in English language. The other way is something that we will see in a bit, which is using something inbuilt that is called modules. That dot format thing is called a module. Now, you can see it's the same thing. My name is there, my age is 25, my mass is 93. Now, I want you to do something. Probably, you can use the force equation inside of this thing. So why don't we write the force equation inside just to, instead of my mass, put the force that Mars is pulling my body on Mars. So, meaning, let's use Python as a calculator. Like, for example, you can do something like print 5 plus 7, okay? Or 5 times 7. Let's see if with format we can do my force. And then mass times gravity Mars over here. Mars. There you go. You see? Now, print is just, technically speaking, isolating one task that he's doing, just output stuff. But inside print, you can put even equations. All right? Print is very, very, very flexible in that case. Okay, so far so good. So you know now variables that are like text, variables that are numbers, and variables that are floating points, we'll like to call them. So in that case, let me tell you, when you are in some kind of hurry and you don't know the variable nature, you can do this. You can write type and figure out what is going on there. So here I present to you the three main types of variables that you will have in almost any language, programmatically speaking. It will be a string, meaning some kind of text, an integer, which is basically rounded numbers, 36, 45, 1,000, and floating things, well, floating numbers. So those are your numbers with decimals, okay? Each of them, you can play with them in different ways. Each of them will have actually different properties inside Python, but just for you to let you know, like strings, integers, and float, that's the basics, okay? And those are the three main different things that you will have to deal mostly. There will be more different other different things that you will have to find along your Python journey, but this is the beginning. Okay, yes, you have a question. Scroll up. Why I use the curly bracket? Okay, because when you're formatting something, when you're using the formatting in Python, each bracket will correspond to each of the variables you want. You have in this example here, like name will go to the first bracket. And that isolates basically the output of print. Print will say like, oh, I have to output this. Okay, let me fetch that value over there from that variable. And this is why the brackets. Now, inside of the bracket, you can do a mathematical operation if you want, because it's isolated outside of print. The only function of print is just to output stuff. Yes. In the format section. Okay, why do I use the normal brackets? So we're going to discuss a thing that is called modules, right? There are inbuilt functions inside Python, like just type. If you see, this is also round brackets. Those round brackets means that this is already a program inside Python that you can invoke. There is another one that is called, for example, len. This one will actually output the length. If I recall correctly, we can use help like this. No. Okay. No, it's just to invoke help. Because if you do help, it usually gives you all the things that you need to know about a function. Here it is. So when you type help, you can actually end up with this menu that will tell you what's going on inside of a function. Now, when I say function, I mean programs that are inside Python already scripted for you. You just have to basically call them. Once you call them, and the way you actually know that these are functions is because of the curly brackets. Format is a special one because format was thought to interact specifically with print with the curly brackets. The curly brackets will allow you to place your variable where you want. And format is just following where those brackets are placed. Okay, but also if we do len, come on. Okay. Okay, so for example, len, it uses basically a logic that allows you to count the characters in a name. And because it counts characters, when I give it a number, it just complains like, hey, I know how to count characters. I don't know what you're giving to me. So this is the complaining that you have. A type error, which is something actually normal in Python. Like you get mixed with your variables and then it's like, what's this? And the type error, technically speaking, is like, just you have to pass me something that I can work with, actually. Oops. So in this case, if we want age to be counted again, we have to invoke another function called str for string, and then it will work. What's happening here is that the str function is converting the variable age into a string, and then len can work with it. Okay, so far so good? Everybody okay? Yes, another question. Okay, when you are using help, go here to the square and stop the execution. Okay, it will take you out. Yes. Mm-hmm. Okay. So the question is, if I have a function and it keeps running and the kernel is basically stuck there and I cannot get out, you have to obviously kill the kernel because otherwise you cannot work. It will not continue and it's stuck there. What you have to do is basically debug why it's stuck, right? And try not to kill the kernel. You cannot just hide the kernel while that's basically execute, because at the end of the day, if it doesn't execute, the program will not advance. So there is something that you have to do first in that particular function to make it work. But that's your custom function. Am I correct? Yeah. For these ones that are inbuilt, they usually doesn't freeze. They just output an error. But yeah, in case of in case of custom functions, that's a different game. You have to first do what is called unit test, meaning make test that corresponds to what is the input, is it the shape, is it the correct type, is it the blah blah blah, and then execute the part that you want from the code, so it returns something, right? So then it doesn't freeze unless you are running out of memory, something like that. Well, good question, but you're advanced. You should be doing this here. Okay, so I'm going to go back to my presentation a bit. Okay, so indexing in Python. We're going to go into indexing. Why? Because for some reason, we have numbers from 0 to 10 and minus numbers, right? Depending on what mathematician are you asking, some things are real, some things are not, some things are unreal. But indexing in Python has to do with how you invoke something. In this case, we're going to see two things at the same time because indexing works all the same. Indexing in Python starts with 0. Indexing in R, the other statistical language, starts at 1. And that's a fundamental difference between different programming languages. So it gives a lot of headache to a lot of people. So for example, if you have the word helium, like our variable name, helium, the indexing, it will start with h in 0, and then m in 5. And for something that is called list, which is a bunch of different variables together, it will be the same. The very first element of that list will be red. So if you do print my list -1, 1, it will go all the way to the back, starting for -1 from helium. I know, it's a headache. But it also works like this for strings. Now, to exemplify that, let's go back, and you have your variable name, right? So if you do name 0, you will get the first letter of your name, correct? If you do name square brackets -1, you will get the last letter of your name, okay? Now, you have 3 different types of brackets so far, right? The curly ones, which is very, very specific for format. The round ones that are for functions, inbuilt things and scripts that are there in Python. And then the square ones are for indexing. Meaning, for example, in your name, depending how long it is, my name is basically 6 letters. So the first one is D with index 0. The last one is not 6. It will tell me, hey, index out of range. Why? Because it starts with 0. So if I put 5, it's the last letter. So this is something that you have to think about. When you're writing something, the index starts in 0. And then you have to trickle down that and basically extract 1 from the index where you want to get. Okie dokie? This also means that you can get a bunch of your name, meaning the following. Let's say you want name, and then you want from 1 to 4. Okay? That's the middle part of my name. Now you can do the same. Actually, do the same. You have your square brackets, and you can put an index there. It could be 1, 2, depending. I mean, unless your name is Anna, which is 3 letters, you're not in trouble, right? If you have a longer name than 6, you can go from 2 to, I don't know, 16. But that's the point of indexing. Like, you can get a bunch of different characters if you know how to slice it. And for example, name, let's say from 2 to the last. So this will read like, out of name, out of the variable name, give me the indexes that start from element 2 all the way to the end, or to the last. You can actually leave it like this. If you don't put -1, it will understand, go all the way to the last one. If I put name 2 to -2, it will give me only those 2 elements that are in index 2 until the second to last in the index. Okay? The second to last. Yeah. The last one is M in this case. That's -1. -2 would be U. So -3, it will be I, and so on and so forth. So this is the way you basically extract just a part of what you want. Well, my name is repetitive, so for example, -1 is R, -2 is here, so it extracts only these 2. Exactly, up to, but not include. Up to the second and last, but not include. That's how you said, correct. So far, so good? Yes. Yes. Okay. This is why, like he said, like up to but not included. It means what I wrote above is like give me all the characters from index 2, which is after the first I, until the second to last index, but don't include it. Meaning go -1, -2 is E over here. Yes. Yeah. Yes. Exactly. You're getting it. Nice. So it's difficult to handle at first. Then you get used to it. Okay. Time for a break. Get your questions on or get caffeinated. And we will start back in 10 minutes. Okay, so I made aware that the feedback form doesn't work for some reason. That sucks, but anyway. By the way, let me introduce you to the Etherpad. This thing is here. This is the web page of the course. The Etherpad is here. If you click there, you can put your questions over here, and I will reply to you in a timely manner. I will put my name here, for example. I always put myself as Tron because I fight for the user and sometimes with the user. But then you can put some nice chat about it here, but you can write here, okay? This is free. Okie dokie. So take this as a collaborative note. If you have something that you have to remember and right now you cannot technically put it in any other place, put it there. It's going to be open for you to write anything, okay? Now, coming back. Right. So let's keep doing some stuff with strings. And let's discuss some other build-off functions that we have here. So far, you all have name, right? If you have your name, you can also have other functions like dot, capitalize, case fold, end with, and so on and so forth. So as you see, when you put a dot and then you do tab, it will open a menu. And this is the magic of why Jupyter Lab was so popular, because it actually helps you to see what's behind the curtains of Python. So for what I like, is like if I do capitalize, well, it doesn't matter too much in this case, because my name is Slim Shady. Okay. So if I have, for example, a string of only lowercase letters, capitalize will take the first one and put it as a uppercase, right? And you just have to add a dot, and then you press tab, and you will see the menu. You can choose from the menu. As a matter of fact, let's check name dot upper. This is something really used when you have all letters are lowercase. Upper will convert them all into uppercase. Okay, so these functions are there, and you can right off the bat use them. It's not a problem to have many other functions working like that. Well, why can you open? You mean like upper like this? And like this, right? And name, for example. Very good question. So in this case, Python has two distinctive functions, like out-of-the-box functions, for example, len, max, min. There are like scripts that are already there when you can do this, upper name. However, there are functions that are tied to a specific type of variable. In this case, upper is tied to the strings variable. Because the type is string, it makes sense to have upper and lower and capitalize and everything. Doesn't make any sense to have upper for integers or for other things. So these are encoded specifically for these cases, right? Now, for example, you were saying len. It has name. This is the usual way you do it. There is another hidden way you can do this, which I don't like, which is invoking like this len. So you do like dash dash len dash dash, and it will invoke again the function. But to me, this is not quite as good as this. Maybe because I'm, yeah, and parentheses. Maybe because it's not like a real case scenario where you will just be explicitly using len. I mean, you have two ways to do the same. I rather, what? Yeah. I rather use the first one because for me it's more clear. Okay. Now, yeah. Let's do, not this one. Name dot swap case, for example. Swap. Yeah, it does the same basically as all upper. So in this case, you have many things attached to the type that you're going to use. Well, what else is there? Of course, round. Something that you all love. The gravity of Mars will give me 4 because gravity of Mars is 3.71. So in this case, max, mean, and len, they are all going to basically be part of the inbuilt functions that you can use. Go back. But for example, here the type of error that is actually telling me is like this object is not iterable. What does an iteration means? It means that to use this one, it needs a bunch of characters, not just like one number. I'm trying to pass min max just one number of gravities, which is not something that I actually need. But if I have something like gravity list, and then I put 3.71, 3.98. Any other gravity that you prefer? Like, let's say 9.81. Okay. Now, see the square brackets. And of course, the main word there is called list. I have, technically speaking, instantiated what is called as a list. If we type, give me the type of this gravity list, it will tell you, hey, it's a list of things. In other languages, this is called an array or other words that say like it's a bunch of numbers. And then I can call max gravity list. And then it tells me who is the maximum. That's the same. I don't have mean, actually. Okay. And this actually is a good moment to start with something called NumPy. So, like you started in this moment, you imported this, and it executed a program that was inbuilt inside of Python and tells you how to use Python, quote unquote Python, if you're not Dutch. So now what we're going to do is to invoke more inbuilt programs. For example, if you write import NumPy, this will tell Python, bring everything that NumPy has into the mix so we can start using it. And to use it, you will have to always call NumPy. You see, here it says module. Now that it's imported, everything that NumPy has is at my disposal. Because it's a module, it means that it's hierarchically on the top of all the programs. And then to start calling the subset of programs that it has, I have to do something like mean, dot mean. So these utilities, as you see, can become very cumbersome, but at the end of the day, when you say import NumPy, you're telling Python, like, bring all the different libraries that you have, all the programs that you have inside into the mix to my disposal. To use them, then I have to tell, okay, from NumPy, on a very high level, give me min, and then execute it using the list. That's exactly what I did here. This is very normal for data science. As a matter of fact, there is a holy trinity of libraries that any data scientist is going to use, and we're going to import them now. But first, something that I like to say is, like, Python also allows you to do short names, because writing NumPy gets old, and it takes a bunch of your code, right? So in this case, we can do something like import NumPy as MP, so for short, NumPy. You can choose any name as long as you remember, like lib1, as long as you remember what you're putting. These should be like on the top of your code most of the time, or if not all the time. By convention, and because everybody likes it, they put NumPy as MP. Then import pandas as PD. And if I recall correctly, import matplotlib.pyplot as PLT. So these three, yes. Has no attribute min. Like if you do numpy.min, interesting. It should work because we're using the same. Did you import NumPy? It's curious. Okay. I will see you in a moment to see that. But for all of you that are still here, so you import NumPy, pandas, and matplotlib because these are basically the trinity of all the tools that you need. Like NumPy will allow you to do mathematical functions like min that are not hardcore Python, and so other numerical and modeling stuff. Pandas, it was the lifesaver of my PhD, because before Pandas, I was actually doing my own parsers for CSV files, comma-separated variables. That CSV files are everywhere nowadays. But Pandas make it actually easier. We're going to use it for some files that I have there. And matplotlib is a knockoff of MATLAB function of plotting, because MATLAB was very good at making plots. So Python decided to get inspired by them and do their own style like that. So to start using this, we're going to use some magic. You're going to do this bash get Python data. So exclamation point bash get data python.sh. Okay. Once more, you do this bash exclamation point bash, and then get tab, and you will get data python.sh. Okay. Execute that. You will see something appearing right now. Now, this is a script from another language called bash that I purposely did to extract all the data that we're going to use in a moment. Okay. So to do stuff that is outside to call something that is outside of the Jupyter notebook that is not Python, you can use exclamation point. And usually this is how it works. So bash get data python.sh is executing a program. Fine. It should have executed by now. And if you go here to files, you will find swc Python. is a folder. If you double click here, you will see data here. And then you can double click here. And then let me put this here like that. By the way, Jupyter is very flexible. Like you can put things here, here, come on, like this. Several files, as a matter of fact. Let's put this here. So in this case, you can have many things at the same time in the same window. But let's go over here. So we have downloaded a bunch of different CSV files. Okay, these are presented right now in the Jupyter lab as a table of Excel table, like Excel is not Excel, hopefully. So there you have country, GDP per capita. You have a bunch of different countries that are in Africa right now. And we have many of these, okay? How do you load this into the Jupyter Notebook? Very simple. Since we imported pandas, we can do pd dot tab. And then from here, what do you imagine I have to select? Go through the menu. Tell me, what do I select? If you do pd dot, and then in the menu, in your own computer, I mean, don't look at the thingy because it's not complete. You will have to go down, 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 down. It has a lot of things, as you see. Okay, give up. Read CSV. As you can see, pandas can read a variety of things. Like, for example, a CSV file, an Excel file. Feather is a type of format that is meant for big data sets. It's like for big data and for basically speed up the reading into the machine and the memory. In this case, we are not that advanced, so we just need read CSV data, okay? As long as this is a function, we need the curly brackets. In those curly brackets, if I do tab again, no, I was missing something. This. Data, SSW, there you go. So if you put one quote and then you enter, you will see SW Python and it says path, right? So this is the way you don't get lost, so you can find your way around it. In this case, click here, Python / data. And then if you keep tabbing, it will deploy all the files that you have here. So far, so good? Okay. Let's load, in this instance, Oceania. Where is Oceania? Here it is. Okay. Close the quotes. If you do this, right now it's going to read something. Yes? To import this. So to download this, you have to do this. Okay? It should trigger the download program. This program is pulling actually the data from the carpentries. So this is data that is public and it's not only mine, it's for everybody. So you can use it for your classes too. Okay? So if you execute pd read CSV file, it will actually read it, no problem, and it will deploy it here. Yes? What if you want to do something with your data in your own desktop? Okay, the same, you will have to give the absolute path meaning all the slashes and all the things towards your specific file. Yeah, so if it's located in documents, you have to go to the root directory and then document, user, documents, blah, 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 until you find your CSV. You can give a very convoluted path. What you can do also is to say, okay, I have this path. Let's copy this. My file. Let's put it better. GDP Oceania. I hope doing this. And now we take this. And then we do the same. pd.read CSV. And instead of the whole thing, GDP Oceania. Okay? Easy to do? I think this is better. When you define like where is your file, and then you just pass that direction, it looks less clunky. At least it gives you also more control over what you want to show. Because let's say like instead of GDP Oceania, you change it to another Oceania file that you have in another place. You just change that variable and you change the next thing. Okay. Now, so far, it deploys this information inside of our notebook. And we can actually store it now as a variable. Instead of doing just pd read, we can put it here like data frame Oceania. Okay. Now I have into the memory this same data. And it's called data frame because, like I said, a fancy word to say a spreadsheet. We can type now this. And now it does says, hey, this variable that you have here is a pandas core frame.data frame. Meaning that it acquires a bunch of different functionalities, just like we were seeing with the strings. Now it has some functionalities. One of those are actually cool because you can do data oceania.info. There you go. And now you have in your screen a small summary of what you can find there. You have different columns, and you see there is a column called country, and then GDP, blah, 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 blah. And you have the data type, D type. You have floatings. As a matter of fact, let's do even better this thing. If we go here and we tell him header, country, how does it start? Country or 0. Okay. There you go. Oh, wait. Okay. So anyway, it was not header, it's index. Okay, before I confuse you more, let's keep this out for the moment. Let's go back to getting this. There are a bunch of other different functions that I want you to check. For example, there is one that is describe, which is one of the better, because it right off the bat will give you statistics. Okay, if you do the data frame .describe, you will get how many values do you have, how many rows. That's the first count. Then the mean value of different rows that you see here. the standard deviation, the minimum value, the first quartile, half, third quartile, max value, and so on and so forth, for all the different columns that you have in that CSV file. So very powerful and very easy, because this will actually get you to analyze something really beefy very quickly. The other one that I like actually is something that's called not describe, but just columns. So here in columns, even I can do this. No, he doesn't like the curly brackets, but if you leave it like that, it will actually get you right off the bat the list of everything that is inside as a column in your data frame. If you don't like how it looks in this way, you see that you have country like in the row, we can transpose it. Transpose. And now you have country on the top, okay? And you have all the values as rows. That's nice to have. As a matter of fact, let's get this into another variable, data temp. And then we're going to say set index. If I recall correctly, it gets the index for that. Okay. No, it's only for pandas. The transpose is a function from pandas. Okay. Dot shape. Another one that is very useful is shape. That will tell you how many rows you have and how many columns do you have. In this case, we have 13 data points and 2. So for your next assignment, you're going to load the Europe one. So do the same thing with Europe. Get the data frame from Europe, GDP from Europe, and call the name and load it into a data frame. Get the statistics from it. Okay? Try it. Pretty much. Good. Yes. If the import from Bash is getting stuck. So you don't have the Gapminer dataset. Yeah, this thing. You don't get to extracting and inflating. And nothing happens? Can I see? Ah, okay. It's because you already downloaded. You have it here. So in this case, just stop this one. Let's remove this one. Remove. Hope it's the same. No. Oof. Yes. Enter. Okay. Now because we remove it. Okay, it's working. It created the thing. Yes. Inflating. Let's see. Code, data. You have the Gantminder data set now. Yes. Now it's all.
PD.
Read CSV.
Oh. Okay, so because previously it didn't.
Okay. No, it didn't work because it was stuck, and it was actually asking, "Do you want to replace the folder I just found?" But now, yeah, okay. Now you can do it with the Europe.
Okay, thank you.
Mm-hmm. Let me check. So for your case, okay, pandas has not attribute read. It's because it's read, not read.csv, it's read underscore CSV. Yeah. Typos, I know. Those happen a lot. Okay, everybody comfortable with the Europe data? You have it loaded? So once you have loaded, you don't. Oh. So this one. After that. So after this, yes. pd.readcsv, add one quote, and then do tab. And then it should show you like swc/Python. It's not showing. You cannot see the menu. That's odd. Okay. But you were able to load it into the memory. You have the variable. Okay. Yeah, no, but I mean like you got to this part, data frame pd.read. But with Europe, actually. What I ask you, like I ask everybody to do the same thing that we were doing with Oceania, but now with Europe. GDP, Gapminder underscore GDP underscore Europe.csv. Okay. So we all have the same, technically speaking, right now. Okay, now comes another part of slicing. Now that you have a very large data set, how do you slice it? Or basic how do you do this with pandas? So in this case, if we do with Oceania, there are two ways of you can use from pandas to locate stuff. Maybe I should do it with Europe. Equals pd.read CSV, then quotes SW data, and then Europe. Okay. So if I just want to see the first 5 rows, I can do this dot head and curly brackets, and I can see that it's already loaded. That's perfect. If I want the last, it's called tail, and this is just 5, the last 5. Okay, United Kingdom at last. If I want some more, I just have to tell n equals 10, for example, and it will give me the last 10. Okay, it's very easy to use head and tail just to see the top and the bottom of your data frame. I think it works only with 10, yes. Yep, it works with 10, right out of the bat. I am a very picky writer, so I like to put all the variables there to know exactly what are they referring to. But Python has this thing also. Yes? Can you sort it? Yeah, sure. But first, let's just go to slicing. You can sort, indeed. As a matter of fact, you can even get everything together into one big group, but that is later. So, for example, what if I don't want like all the countries, right? You can do something like data Europe dot ilog. Okay. Now ilog is special because the I stands for index. In this case, the index could be 2, 3. And obviously, I'm referring that in that sense, you have rows or you have all the rows of Belgium, for example. Or you can get all the columns. Give me the columns. It doesn't be like that. Yeah, there you go. So it's a very picky function. However, you use the square brackets just like you were slicing before. Then it's going to ask you, tell me the column and the row that you want. In this case, it's row and column, if I am correct. So if you can do 2 and 2 or the meaning of? Yes, the meaning of the column is all. As a matter of fact, in theory, the correct way to do this will be like using the column and saying exactly where you want to land, like 3, 3. But just like slicing, it will be everything until this point, but the last one. 3, 4, 2, 3. And then you have GDP per capita in 1975 of who knows what. But you can get everything like this. So we know now that is the GDP from Bosnia and Herzegovina. Is that still a country? I guess so, right? So you have basic 2 columns out of one row. So remember, first is rows and then is columns. And then it depending on what or how many you want to get, you can get all these different rows if you put minus something, and it will take out the last 4. And so you can slice a lot. Let's do 0 to, I don't know, 7. So in this case, you can get basically using the indexes of the table if you know the table. But this is ilog, okay? So keep in mind, ilog is for index. You need numbers. There is another one. Yeah, the scheme, they tried to make the scheme of the slicing pretty much the same. This one includes the columns because you are talking about large tables, right? So you may want just a couple of data points and not all of them. Like, for example, if you go from here to here, you have this small sample, right, and the whole sample. It's a good practice to sample something. But then you have also something that is called lock. So lock will try to get strings, meaning like you have a string here and string here. What do I mean by string? Then yes? Yes, you could. Yes. What I mean is now you get to play with the numbers that you have here in black and the names that you have here. Because in this case, you will have, for example, 3 and this one. Takes 1 and 2 positions over given. Okay. It doesn't like it like, okay. Duh. Again, doesn't like it. Curious case. Let's see if it wants to try it with Denmark. No, there is lock and there is iLock. So lock, in theory, I must be doing something wrong. So here should give me this. No, it doesn't like it for some reason. Yeah, let me do something. Index, set index. I want the column called country to be the index now. Not define country. Country. There you go. Okay. So maybe this was the mix error that I had. So I already find the variable there. And then let's do dot lock. There you go. Then let's say Denmark because it's here. There you go. That was the error. So my error was that while I load the data frame of Europe, the index that you see here is in black, 3, 4, 5. It didn't like it. So what I did was to tell, okay, set the column country inside of the data frame as index. This is what this line says. And then because now the data frame of Europe has this column as index, check it out. You see how now it's all highlighted in black? Now I can use lock and I can tell him, okay, give me all the GDP points for Denmark. So if your index is actually a string of letters, you can get it from it. Now let's say Bulgaria. And now we do the same thing with Bulgaria and let's say to Bulgaria to Denmark. Okay, so iLock and lock has the same structure. However, the difference is like with iLock, you need a number. the number of the index and the number of the column. With lock, if you have your index as a number of strings, that might happen, like for example, genomic reads, genes, names, or whatever. If you set it like that, then you can say, give me from Bulgaria to Denmark all the GDPs, and then you get all the GDP points. Okay, that's slicing and everything. So far, so good? Yes. Ah, where? Why is Denmark not in? Ah, yeah, like is that? Yeah, you mean it's like. Mm-hmm. Ah, okay. Yes, you're right, because usually the logic is give me until this index, and but not included, right? Now this one is actually doing a very very localized search of the strings that you are telling it. So it's actually obedient or is actually following your actual logic that is happening. You're telling it search for these strings, and it search for this span of strings until it finds Denmark and start from Bulgaria. If we attach to the slicing of before, that it was like all the indexes but the last one, this shouldn't happen. But they fixed it because it was actually excluding data points. In this case, you know exactly which data points you want, including that one. But for all the other indexing things like strings and lists, it will exclude the last for sure. So yeah, thank you for pointing that out actually. This one is very specific. It's skipping it. Yes, the user will have control over what you want to slice out of the data frame, which, I don't know, more power to the user, I guess. Okay. Ah, the index change, yes. So there is one thing called set index, and this command will set the index according to the names of the columns you have. We used to have a column set country, and that will change the index. Okay? Yes. Yeah. You mean in the lock? Ah, yeah. But look, the logic of lock is to leave that numbering thing to iLock. But yeah, before we had the index as numbers. And then lock could actually fulfill it, but I didn't write it correctly. This is why it was failing. I changed that number for the name. Now the logic of lock is just do the strings. Yeah, as long as you know what you want to get out of the data, use whatever you want. But it's a subset, yes. How do I get the headers of each column? Like, you mean data frame Europe.columns? Okay, like that. You invoke the columns. You can even invoke the index. Dot index. You have then the list of all the countries there. So this will tell you, like, pandas can do things with Excel very, very fast. You can get information quite readily, easily, with a couple of just dot something. Okay, so far so good? Now, let's do something fun. With Europe, let's do, data set Europe. And let's do .log. Italy. A very conflicted country. And then Poland. And I like, let's say, GDP, what is it? 52 to GDP let's say 97. Okay, so now I have, let's do not 97, let's do 72. Okay, subset of Europe. Nice. So what I did here is basically get a couple of, just a subset of the different data points that you can see. The data set that we have Italy, Montenegro, Netherlands, Norway, and Poland. And the numbers are fine and everything. You can review them one by one, but you also can basically filter them. So what I mean is, like, pandas can actually do some specific operations right off the bat with this kind of subset, or with all the data set. For example, if we do print subset, yep, and then equals 1, 2, 3, 4, 5. So what you see here, it's a bit clunky. Okay, there you go. So what you see here, technically speaking, is what people call a mask. What I'm telling Python is, like, print true or false where you find a data point that is greater than 10,000. So that right off the bat will tell you where to find those points, but it's just true or false. And you can use this mask to basically just filter what you want in this way. So if you have subset of Europe, and then you tell it subset of Europe 10,000. Okay, what I'm telling here to Python is, from the subset of Europe, go and get me all the points that are greater than 10,000. When you do that, it will take all those points, and those that do not complete that greater than conditional will be marked as not a number, or none. This is called using a mask, okay? Because all the points become not a number where they don't fulfill, where they were false. So you can see, like, for example, Norway was always rich than 10,000. Well, he will always have this kind of number. Italy, until 67, they reached that number of GDP per capita. And the Netherlands had that before. Poland has never had that during that amount of time. So you're already into telling a story. You can say who got first to that number. Okay. And even when you have this, you can attach more stuff. Wait. Like, you can do the same thing and then .describe. And now you can go and tell your boss, oh gosh, this again. And then you can go and tell your boss, hey, from this subset of countries, we have this mean value across different time during these years. and we have a minimum of this number or a maximum of that number, blah, 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 telling them the story like for this specific subset of European countries, we have this kind of behavior. And it's quite readily in one line. So for that, we can still do a lot of other things with the pandas. The next part is going to be about plotting, but right now we're going to take a break. Okay? Okay, let's take a break. All right. So I'm glad that you're still here. You're still alive and breathing. I told you, it's very dense at the end of the day. Okay. Now we're going back to Data Oceania. But now I'm going to load it like this. To avoid the problems that I had before, I'm going to set who is the index. Read, what was the variable name? My path? No, GDP Oceania. Okay. If I do this, GDP Oceania, and then I say index call, I can actually tell it use country. And this should automatically give me data frame, Oceania, country as an index. Okay. So we need basically right now the countries as an index because we're going to plot their GDP. Very, very easy. But first, I want to do some editing. As you see here, we always have GDP per cap underscore something. But we know these are years, right? So is that bit really necessary? I don't think so. What we're going to do is something really nice, which is playing with all the things that we saw so far. Dot columns, for example, we know that this will do the columns. Now, for the columns, we can do str, which is treat this as a string, and then replace. So in this replace, you will have to put GDP per cap underscore, and then double quote. So what I'm telling Python right now is from the data frame Oceania, bring the columns, those columns that we see up there, and then treat them as a string and use the function replace. So whenever you find GDP per cap underscore, replace it with nothing. That's all what it says in one line. And if you see it, I just eliminated all the GDP per capita thing. Okay? So replace has this notion of whatever you want to replace with, you put it in the first couple of quotes, comma, then whatever you want to do next. Because you could put just here also GDP, and it will be like this. But in this case, I just want the numbers. I just want the years, because I know there are years. It's evident. Okay? So far, so good? How to apply exactly? Very good question. How to apply these changes in the data frame? First, we're going to call this as a variable year. Okay? The second thing that we need to do to apply this is data Oceania dot columns and then equals years. One year in this case. And now when you see data Oceania one more time, now it changed. Now you have eliminated GDP underscore all the time. Okay? And this is how you basically change all the columns. And if you want to actually change the names of the countries, you could do that too by transposing. Transpose. When you do transpose, your countries becomes your columns, and then you can apply the same thing. We're not going to do it right now, but you get the idea. You can convert all the names of your columns into whatever you want as long as it matches the same number. Okay? we did something really fancy here. It's like, okay, from the data frame, give me all the columns that are a list, then treat them as a string, then replace them with I want. In one line, super fancy and very complicated to do in, for example, C++. So right off the bat, now we have a different data frame that it looks like country and then all the GDPs by year. That's nice and all, but then we can do something really, really easy, like data frame Oceania.log and quotes Australia. Okay, I have all these data points. Now, because remember that line that says import matplotlib, blah, 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 that we did long ago? So this will be handy because inside of pandas, we can invoke that just by doing .plot. And now we have a plot of these years of just Australia. Okay? So with this plot, we can start telling a story. Like, all right, so the GDP of Australia has been increasing for over the years. If we want to do both at the same time, you just do log nothing and plot. Now, as you can see, here is kind of wonky. It's not depicting the right story, right? Like each line is, technically speaking, one year. And where the heck is Oceania and New Zealand? New Zealand, should say. But if we transpose that, then we got a better picture. Now, the transposition was important because first we have a data frame that was like this, and we just got Australia and all the numbers fall in place. If we transpose it, we have it like this. And then matplotlib is actually smart enough to know the difference between one of the others. And now you can tell a story. Like, if you see it, it's like, okay, Australia has done better in GDP terms than Oceania, which is, okay, normal, I guess. New Zealand is a very small country. Now, I want you to do the next task. I want you to tell me the story of the GDP per capita of your favorite European countries during the World War I. Except Italy, they did terrible. So now is your task. Use the Europe data frame that you have loaded and give me the same kind of plot. Select only the years for the Great War. Yes. Over here or over up? Ah. Yeah, the log worked because I used to have like as index Australia. No, this is before transposing. When I did it without transposing, if you do just this, it will tell you, it will write all these lines, which has no meaning. If you do data frame Oceania dot transpose, and then dot plot, that's all. Should work. Okay, capital T. There you go. With capital T. So now it gets the right story. And what I want you to do basically is the same thing with Europe. Select your favorite countries. Or do a subset of two. Yes. What happened?
Looks like the connection is low.
Oh no, the connection is lost. Yeah, that's odd. But you do have. It is interactive. Stuck. Oh no.
Yeah, this
But curious. Maybe it ran out of memory. Okay. If you want, you can reload things, but you will have to do the bash thing again.
yeah.
Yeah. But that's one thing. That's one solution. You can download
Do
what
you
we
know
have
why
there.
what is the reason?
I really don't know. I thought everything was going to be smooth
Yeah,
until that one.
Yeah.
Yeah.
But
No.
after that,
Yeah, I don't know. I don't know why the instance didn't work. That's pretty odd, really.
I will
Yeah. Hmm?
The plot is not showing up. If I run it,
Mm-hmm.
there's an empty. So
No, it's still running. Yeah. Yeah, you have the same problem as hers.
Okay.
Exactly the.
but I imported the matplotlib as PLT.
Ah, no, but we still not. It's not an issue yet.
Okay.
Huh. I don't know.
I rerun all the because when I came back from
Yeah.
the break, everything was gone. I have to re-import everything
Yeah, yeah.
and re-import re-download the data and do all the analysis.
Yeah. Okay. This seems to be the problem also for her.
Okay.
You have to reload the binary hub, download the.
I did it already.
Okay,
Yeah.
and yeah, run it again, which is I don't
Again
know.
one time.
Yeah, I don't know what it happened.
Okay.
I guess you got disconnected at some point.
Okay.
Are you on the Unify web? You're in the Unify also? Yeah, you're in Unify. So it's not an internet thing. Okay.
Okay, I'll just wait.
Yeah, I'm sorry.
Oh, no worries.
Yes.
Use the plot
Uh-huh.
the log. I think it's following it. There's three errors. I can't find where in the syntax it's incorrect.
The index. So here, what we have to do is Oceania. Let's go back to where you defined it. All the way up, right?
Yeah.
And a bit up. Okay, so in here, we're going to do index call and quotes, and we're going to say country. So country, okay.
And why are
Net.
we doing that? Actually? Like we are giving, like saying that the index should start with 0. 0 should.
Instead of 0, it will be the country, yes.
Okay.
So in this case, you will have now the index, the name
Yes.
of the country,
Ah,
and now
okay.
log will work like this. And you have it there.
How are you play button? How are you executing?
To execute this, Shift Enter. Okay. Okay, from dataset Europe, let's see. Let's log. France. Italy, Germany. From France to Germany. Oh. There you go. No. I think this is that. Yeah. Nice. Columns dot str dot replace. And then the same thing, right? Okay, so technically speaking, you have done this, right? Quite straightforward, like get a subset, replace the GDP pair so you can get clean years. Okay, so now we're going to modify the plot because obviously this cannot go into your PhD dissertation. Not like this yet. But we do have tricks for looking better. Now is when we are going to start to use PLT. On the same cell, okay, let's leave it like this just for the example. But on the same cell, you can do plt dot ylabel. And you can say years. Correct? Oh, this is not years. It's the X label. So very quickly, we fix that. If we want to do the Y label, it's the same thing. PLT Y label, and then we have to put GDP per capita. Very easy to modify, right? Okay, not quite great yet. Actually, we can use another thing before the subset. We're going to change the appearance. PLT dot style. And here's when you get the best out of it. So for those of you that know R, ggplot is the library to plotting stuff. And actually, it gives you back something really nice to show. If we put style ggplot, and I think there is also a style paper, you can get right out of the bat the style that you want. Now, here you have basically the story of Europe, right, in GDP per capita, which each line corresponding to one of the different countries. Even further, you can set the label, the color Padlet, to be colorblind friendly, because there is colorblind people, and some of them will not see the red over there, right? So if you go all the way here, now you have a very nice graph to show. One more thing. This is not the only thing you can do with, I mean, look the difference between this and this is pretty nice. However, we can even do further things, like, for example, instead of just plot a line, you can say kind equals, I think, bar would be good. Now we have a different kind, and it's just one thing that you have to add. If you do just plot equals kind, and then between quotes scatter, it will be now points. The default is a line, but now these also show like kind of how they were growing. And because of the colors, you can tell a history. So as you can see, like the population of Europe started to grow, and then the GDP per capita started to grow. It's not because they were very good at tech or whatever, or very good at war. They just have more people. That's one of the reasons. The other could be that they actually had some kind of technological advance that allows them to have more money than other countries. Okay, so far so good. Now you can tell a story with your data? Kind of. Nice. Well, okay, let's go back a little bit to hardcore Python. Now it starts the part where everybody likes to automate things, or automation. For the next part, we're going to discuss something called for loops. And this takes me back to this. Okay. We already saw that we can define lists like that, like odds. You have your square brackets and then your number of odds, 1, 3, 7, 9, 11, right? So if I have a very long list of whatever, like for example, the names of, or the years, how do I go about it and do something with them? So this is why you basically go over recursion or iterative things. For loops does exactly that. And what you have to just remember is like a for loop says like, for every number inside of my list, do this. And the logic behind it is like, for each odd, or for each element of the list, it goes and does something. For example, that do something is printing that number. So the code is really simple, and in Python is straightforward. If we have odd numbers, even better, data frame Europe dot columns. Okay. If we do for years Europe in columns. So each for loop has to actually end with these 2 points. This is what triggers inside the Python syntax. Like, this is your statement, what you want to do with the recursion. The next line will have an indentation. Come on. Okay? So what I'm doing here basically is very simple. For each element inside of the years list that we have already, I'm just printing that year with my ugly typing. So this is the way you go into recursing something. Now, the trick here is like Python doesn't like not to have indentation. If I am not giving him a space there, it will complain. And this is another normal error. Usually, this is three spaces, but it could be tab, it could be different things. However, Jupyter Lab does it for you. And still, it will look like this. Now, we can do a variety of things because that's basically the body of the for loop right now is just print. But you can do other stuff like print mp.min close parentheses. Doesn't like it. Okay, let's do max then. There you go. So for each time it goes inside of the loop, it's just creating that, executing that max function that we already have, which it will always come back as 9 for some reason. 9 here, 9 here, 9 here, 9 here, 9 here. Yeah. Yeah, it's doing that probably. But also you can do printing and slicing stuff. Like 0, 2, 3. Makes no sense, but you get the idea. So in the body of a for loop, you can put all different things. And what usually you will put if is conditionals. If, like I'm saying, like literally the conditional if. There are 3 things about if. It has 2 partners. If, else, and else. These 3 things will allow you to basically jumpstart or execute one fraction of your code or not. Let's do an example, and it always ends the same, basically speaking. So if year greater than 2000, then print that year. Doesn't like it. That is not an integer. Very easy to fix. We just convert it on site in an integer. So I cheat a little bit because years so far is like a string because we replaced the GDP per capita thing. Now I have to convert it back to an integer, and I just call the function int to on place, convert it to a number because I know it's a number. It's just 1970 something, right? So for years in the data frame columns that I have, if my years are greater than 2000, print that. So very simple, very straightforward. What if you want to do 2 things instead of just altering for 2000? Let's say else print, let's say too old. So here what is happening is like every time it's starting the for loop, it's evaluating if years is greater than 2000 and printing that. If not, else, then it will just print too old. And it prints too old every time it's not convinced that it is able to fulfill that conditional. Very simple, and this is basic block of everything that Python can do. As a matter of fact, people say that AI is a bunch of this, which could be true, because there is a lot of different conditionals that you can put inside of a Python code depending on what you want. Now, for the last part, it will be else if years equals 2002 print like this. Now, what I'm doing here is actually just exemplifying like the hierarchy of the conditionals. In this case, because the first conditional gets fulfilled, the second one, el if, which is basically if the one doesn't work, then do this, doesn't print the GGG. And then else, everything is too old. Okay? Let's create something a little bit lower than. So in this case, now the condition has basically changed. And now it's printing GGG because the first condition gets fulfilled only by 2 members of the list. The second condition gets fulfilled for any number of them that are actually lower than 1992. And only 2 of them are too old because those are numbers that are lower than and not in the range. So if you follow me all the way to here, and you can do this kind of thing, then congratulations, you're done with this workshop. So this is actually the power out of many of the program scripts that you need, because what you want is to iterate over something. In this case, we iterated over data, over the columns, actually, not even the closest data. Now, can you iterate on the data frame? Why don't you try it? Give it a try. Work a for loop where you basically filter only those data points from one specific country that you want, for example, Italy, and then select only those years or print those years that it went beyond 5,000. And if you're still like spiritually here, this is the folders you will get. Okay, this is the last part of the workshop. So in this case, if you want to do the for loop, go ahead. If not, that's okay. Yeah, and we're just in time for another break, but I will have a democratic vote. So do you want to take this even further, or shall we stop? Because it's already like 3-4 hours, right? So in this moment, I see that everybody's tired. So let's do a break right now. Okay? Fine? Break. Test. Okay. So my battery has died. Okay. Just one last thing, and we're done. So since you have been excellent and you're still here, let's do something that could actually help you to do a bunch of other things. Where's my, here. There is one library, it's called glob. I don't know who came with this idea of calling it glob, but we're going to import it. Okay? What glob does is actually allowing you to use glob for global. Now, when you use this, is because you have a bunch of files that you want to actually search and look at. We're going to go to data like this. And then, if I'm correct, if you write like this, it will tell you, okay, the type is just a list. Okay? If it's a list, it means you can actually iterate over it. However, what happens if we do *CSV? This is what happens. What glob is doing is, technically speaking, going inside of a folder, and then it's giving you all the things that match what you have written. This is a part that is very extensive, and it's called regex, because you have some characters special that trigger something. Okay? The most used one is the star. What I did here was, okay, glob, give me your program glob to go over the different data files. Use this folder path, data, and give me back everything that ends in .csv. Okay, that's why it's so used. And as you can see, it gives me back the list of all the CSV files that are inside of that. We can actually check it, right? It's all this here. There is one that's called small, inflammation, gapminder. These are the actual files that you will use for other Python lessons that we have. But right now, we can get these into one list, which means we can iterate, which means we can load them with pandas. As a matter of fact, we can use a if conditional just to load, the inflammations or all the GDPs. And we can exclude, for example, there was one that says gapminder all, which is over here. We can exclude that. Okay? So let's do that together, right? Now that we know that this is a list, let's go and say, okay, for my CSV file in this list, okay, what are we going to do? First things first, let's say, okay, I want that if gapminder the word gapminder is in my CSV file, print my file, CSV file. Okay. Now, what this should produce, in theory, what I'm doing is go over the whole list, and it's very basic, but it's very straightforward. If you have the word gapminder in those strings of letters, then you should print it. And there you go, all in all. Yes? Yeah. As a matter of fact, it's a list of string. Right now, glob is treating the path as a subset of strings. But because it's a string, you can actually tell Python in the following way. If you find gapminder pattern like that in this string, give it back. That's what we did. However, because it's a path, we will use it as a variable to load it into pandas. I think I confused you more than I explained things. Why isn't a specific library for searching all the files? Okay, so there's libraries for everything in Python. This one, there is no other way to actually say, go into this place and get me all the files. So far in Python, you would have to do each one by one. Yeah, now you can do thousands if you want. There is no restriction. We have only 10, right? About 1, 2, 3, 4, 5, 6. And this is nothing, but there are some places that have 1,000 CSV files fragmented forever. Ask any genomic guy that you know that is doing biology. They love these kind of small files all over the place. And they have to put them back together into something. So glob in this case just give you like, okay, give me the path, and then you just have to use the paths where you know where they are stored. That's one way to do it. There are other ways to do it. You're totally correct. But this one, for example, this is glob. The other one that you could probably are asking, there is one that is called OS. We have to import it actually. Import OS. So with OS dot it was system dot, or it was system dot sys. No, not this one. This is path. Oh wait, os dot path. Yes. Dot list. Actually, we have this one, which is this. Where is path OS list here? Here it is. Duh. So if we do this, for example, one missing, it will give me back exactly the same. However, the power of glob is that if we have other type of files, because these all are CSV file, I cannot do it with list dir. I can do it with CSV file, with this one. That's the difference between glob and OS list dir. However, if you're more like a Python IC specialist, you will use OS list dir because you know exactly what you want to get out of it. But things change. And for example, just glob is easier just to put the regex pattern that you want to filter first. So in this case, let's continue with this one. So far we have a list. Nice. How do I filter now to get rid of gapminder all? Very simple, as a matter of fact. If and all not in, okay? So for you, this is for you to understand, like the if conditionals are technically like speaking English. So in this case, what I did was if gapminder, this string is on the list, get it from it. get rid of all the inflammation thingies. That's nice. And then all that are with all in the name, get rid of it. Don't print it. And we can do the same basically for inflammation if we wanted. Very nice. Now for the next thing, we can just definitely load it into Python, into the memory. How? We can do data frame equals pd.read CSV file. And then my CSV file. Okay. So far, in this part of code, I'm going to load 5 different CSV files. However, every time that the for loop starts, that data frame variable is going to be erased and load another thing. So I need somewhere to save that information, correct? Usually, what you can do with pandas is store it in data frame list. You initialize an empty list like that. Very easy. And then, okay, you say data frame list dot append df. Okay, this is basic instructions, but these will go over a list of files that you have, read it into the memory, save it somewhere, and it will save it in a list, in one element of the list. As a matter of fact, if we execute this, I know that it read all this here. If I just check this, it will tell me about all the information that I have stored there. It's not quite good, it's not quite readable, it's still a list. And very long, actually. You see? Data frame. What we could do with pandas is actually concatenate all of them. And we can do pd dot concatenate and concat. It will ask you for the axis, but it will ask you basically for the list. And it will tell you, okay, I concatenated everything in one single place. Obviously, we can save it as data frame all EDP and now I have my data frame just like before, and I can do exactly the same. Describe, and I have for all the world the statistics. I can do info to get a very quick glance of what I have in store. I actually can see that I have non-values here, GDP per capita and so on and so forth. So you can start playing with pandas even larger and longer. And because it's a data frame now, you can start playing with the index, get a part of it, and then compare, I don't know, one, like United States versus Germany versus Australia versus Botswana. So at the end of the day, what I want you to get out of this last part is that you can get all the information with one simple for loop, which is technically speaking 5, 6 lines long. And you can iterate over larger data sets, like huge data sets, and place them all into your memory, and then very quickly get all the information that you want from the statistics. Okay? So that's basically the last one that I want to tell you. And with that, we will stop the workshop here. If you have any question, any regrets, any other things, that's fine. Yes. Yes. Ah, good point. I didn't write anything so far. You can write things with pandas too. Thank you for reminding me. So all of this information right now, pointed out, it is on the memory. But we can do data frame all GDP dot, and then you can basically say, okay, I want this to be, I don't know what type of output you want. Many people does Excel. I don't understand why. But you can do this as an HTML, also a JSON file, even to LaTeX. But I mean, this information to LaTeX doesn't make any sense. But to CSV, okay, we can just output this again to CSV. And here, you have to give the name of the data, basically. My data frame .csv. And you have a bunch of other things that you can do. When you do comma and then tab, you can get an insight of all the other options that you might have. You can say index, whose header, blah, 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 encoding. If you want a number of decimals, like to reduce from 4 to 2, something like that. Or even chunking in the sense of give me just small batches. But in this case, just let's output this. And now where did it run? Here with me. You see, here's my data frame. Because I didn't specify where to put the CSV file, it just put it there where the notebook is running. But I could do exactly the same thing as SW Python data slash, and then it will save a copy on this very normal looking folder. My data frame is saved here. The same with Excel, the same with HTML and everything. You can tell it, put it here, not there. And you better be organized because usually things get messy. So the data and the results, put it in one other folder, your input in another, and so on and so forth. But thank you for reminding me. But yeah, that's the end of the workshop. Thank you for staying this long. And if you need more information, like I was telling before, if you go here to the training, there is material over here that says Python Novice. This Python Novice is all the material from the carpentries that, for example, I didn't cover a variable scope, sort of I covered it, and programming style. But there are more exercises here that you can go through, and they will actually help you to get more idea of how to use Python. And you can use it in Binder. The Binder is there for you always on. Okay? If you're brave, actually, if you're brave enough, you can install Python in your computers and then run it locally. But there's the material for you whenever you want. All right? Well, thank you very much. And yeah, see you. By the way, next Sunday, if you're going to use our cluster, come to the auditorium between building 4 and 5. There's the data science onboarding thing, register. And also next week we have more. What was it? Where is it? Here. Yeah. Go back to training. So next week, my colleague Abdul Rafur is delivering machine learning, deep learning, and Docker. So machine learning basics, if you want, deep learning, you will use GPUs there. I'm not sure if the GPUs are going to be IBEX or not, but he's very good at delivering these workshops. And lastly, the one that is Introduction to Docker is a very good tool for reproducibility. Alongside with Conda, that's the best way so far in these years. How do you reproduce a computational thing? Okay? So yeah, register if you want. You're welcome. And well, thank you very much for enduring this workshop. So this is all. Thank you. Closing.